Hello and welcome to a quick video on how to make a graph in, this one's going to be in Microsoft Excel. There was another one on Google Sheets. But how to make a graph in Excel that will get you all the points for me, and also how to analyze the graph when you are done. So here's the general idea. In general, for graphing, most of the labs will require graphs. And I ask that you do not hand make the graphs. Either use Excel, Google Sheets, or some other program. I recommend one of these two. Excel is the one that's easiest to use, which is why I recommend Excel, but it's not, not everyone has Excel. Google Sheets, you all have access to. If you want to use another program, you can. I'm not going to give you a video on how to use another program, only those two, because that's the only two I know. So this is going to show you how to do this and how to get full points. And here's the idea. The point of a graph is that all the information can be figured out by reading it. Everything's labeled, everything's clear. And what's going to happen is each time I'm going to ask you to graph y versus x. I'm not going to say y versus x. I'm going to say something like, you should graph m versus x. Or for maybe it'll be f versus, f versus a. Or maybe it'll be p versus t over v. I'm going to ask you for something versus something else. However, the order I say it is important. If I say m versus x, what that means is m is y, x is x. You need to keep a track what goes on your y-axis, which is the vertical, and what goes on your x-axis, which is the horizontal. And it'll always be the order I say it. When I tell you to graph f versus a, f is y, a is x. If I tell you to graph p versus t over v, p is y, t over v is x. And if I ask you to graph m versus x, m is y, and x is x, which is kind of nice and makes things easy. Now, before you can make the graph, you will need your data. And let's say you collect some data. You should have a large data sheet in any given lab. It'll probably be not just one thing, but tables of data, as I grab one without a table. It'll be tables of data with all sorts of stuff. You don't need to add that all into the graphing program. You just need what you graph. And what I recommend is you enter the data with your X data first, your Y data second. In this case, since X is X, that goes in my first table. In my second table, I'm going to put my Y, in this case, M. Now, that means you got to sit there and type it into Excel. I already did that. And here you go. And here's that data. I put my X data, then put my Y data. Now, as I said, how to do this is different for Excel and Google Sheets. Right now, I'm using Excel. If you're using Mac or Windows, it should work basically the same. When you want to make the graph, what you should do is you should start by selecting your data. And do that just by clicking in the middle somewhere, clicking and dragging. Note that if you move your mouse to different spots, here I have a little white cross, here I have a black one, here I have a hand. If you have like a hand, you're going to move the data cell. If you have the black cross, you're going to go and overwrite all your data. Make sure you start in the middle so you have this white cross and select the data. Once you do, you're going to go over up here to where it says Insert. Once you have Insert, you're going to go to this recommended chart section. And the chart you want to do is the scatter plot. How to do the scatter? Really, you can hit any of the graphs, but if you get this XY scatter, click that. And once you click that, just use the upper left one. There you go. There's my chart. Now, this is data in a nice line. Looks good, but this is a useless graph because I'm looking at this and I'm like, cool, dots. What does that mean? When you have the graph, you must make sure everything is labeled and clear. That means knowing what's on your x-axis, knowing what's on your y-axis, and getting something from the slope. How you're going to do that is the easiest way is still in this. If you click the graph and go to chart design, in the upper left will be quick layout. Go to quick layout and just go to this upper left one. What that does is it gives you these axis title things. And you're just going to go on the axis titles and just type and replace them. This is the x-axis. In this case, my x-axis was position in meters. This is my y-axis. I'm going to take my y-axis and place it as mass in kilograms. Honestly, I don't really care too much about chart title. Officially, this should be M versus X. But sometimes when labs have multiple parts, I also take part A. Or if you just leave that blank, I don't care. That's the first important thing. You must label these axes. Once you label your axes, the next thing you need to do is you need some useful information. This is dots on a line, but this is not giving me anything. See, we're going to use graphs to take information. And so what you're going to do is go onto a data point and right click. When you right click, there should be a thing saying add trend line. Hit that. And you get a trend line. But this trend line is still not very useful. It makes a line. But over on the right of the screen, there should be a format trend line section. If you go to the format trend line and click display equation on chart, and depending on what you're doing, you might have to scroll down a little bit, you'll get an equation. An equation saying y equals 0.9823x plus 0.0009. And it's like, cool, we have that. And that's what you want. But the question is, what does that mean? So if I go back to my PowerPoint, for a straight line, all straight lines follow the equation y equals mx plus b. What that really means is y equals the slope times x plus the y-intercept. Now this line is y equals 0.9823x plus 0.009. But now before I get into it, the first thing is in this class, you can always ignore the y-intercept. This 0.0009 doesn't matter. And what that means is y is the slope times x. Now in this case, we're graphing m versus x. That means our y value is the mass, and our x value is that distance. But we know, well, once again, y equals 0.9823 times x. That means the slope of the graph is 0.9823. That x times 0.9823 is m. We can see that directly because 0.9823 just is the slope. Now keep in mind, slope does have units. The units of any slope should be the units on y divided by the units on x. In this case, kilograms divided by meters. But I'll always have a section say, what is the slope? And for the slope, you would just put 0.9823 kilogram per meter. Don't include the 0.0009. Don't include a y and an x. Just give me the value and the correct units. Now, from the physics involved, I always relate this to equation. You wouldn't know this yet because we haven't covered it in class, but there's an equation that says m equals k over gx. Now, in this case, we're saying m is the slope times x. That's what we get experimentally. But physics says m equals k over g times x. And so x times something is m. You get from both equations. And logically, comparing, I can see that the slope should be the same as k over g. Now, I'll always give you an equation such as slope is k over g, or slope is nk, or something like that. But you're not going to use those equations. That's just showing how we get the steps. You see, when we make these graphs, our goal is to find something. I didn't cover this yet, but our goal in this lab that I'm stealing this from was to solve for k. And what we did is we found the slope. The slope was 0.9823 kilogram per meter. But we know the slope is k over g. And if I rearrange that, that means k is slope times g. I just multiplied both sides by g. And that's how we solve for k. And so when you do a graph, you should always have a graph that looks like this with both axes labeled, a trend line, and an equation. And from that equation, you will get the slope. And from that slope, you will plug into equations given to you in the lab to solve for some other term. Now, if you're in my physical science class, you can stop here. That's all you need to do. And so physical science people, you're good. Feel free to sign off. But if you have me for physics 1 or 2, I'm going to ask for something else. I'm going to ask for the uncertainty in slope. To get the uncertainty in slope, let's go back to our Excel. If I want to find the uncertainty in slope, I have to do something called the linest function. What you're going to do is you're going to select 4 squares by clicking and dragging, 4 empty squares. And without clicking, type, equal linest, open parenthesis. And you can see it starts to autocomplete, known y's, known x's, and so on. I'm going to start by selecting my y. So I will click and drag over my y values. Hit comma, click and drag over my x values, comma, then hit comma again, and type the word true, and close parenthesis. Now this part, you're not going to be able to see what I'm doing, but just you're going to have to trust me. I can hold this up. You're going to need to hold down Control and Shift and press Enter. When you do that, all 4 boxes will fill. If you do not hold down those keys, it will not work. And you're going to get 4 boxes of information. Now, this first box should be exactly the same as your slope, because it is. And this box here, that's your y-intercept. You get the same value. Once again, we don't care about that. But this is your slope, and this value here is the uncertainty in slope. That is your uncertainty. Whenever I ask for uncertainty in slope, that's the value you need. By the way, this one's uncertainty and y-intercept. Also don't need that guy. Now, what you're going to do with that, what that means, is that if that's the uncertainty in slope, that means the slope of your graph isn't just 0.982. It's 0.982 plus or minus 0.0059. I kind of rounded wrong, but that's just because I wanted to not have zeros. Because that right there is the uncertainty. That gives the slope a range of values, anywhere from 0.982 plus 0.0059 to 0.982 minus 0.0059. Now note, uncertainty in slope also has units. The units of the uncertainty in slope is the same as the units of slope, kilograms per meter. And yes, this would give a range, but you normally don't need to find the range. What I'm going to ask for is you to calculate the uncertainty. In this lab, I was showing you're solving for k. And then I asked you to calculate the uncertainty in k. How you're going to do is you can use the uncertainty in slope. You see the uncertainty in the slope is 0.0059 kilograms per meter. And I'll give an equation. And whatever equation I give for, in this case, uncertainty in k, that's what you can plug into uncertainty in slope. And that's how you do it. Any questions, feel free to ask me, shoot me emails, come to my office hours, and so on. But that's the process. That's what you need to do. Good luck.